Hi everybody. We are going to talk about types of triangles today. So there's two different ways to classify triangles. We can classify them by their angles or by their sides. So the first way we're going to do is by their angles. I'm going to kind of have you split this chart up a little bit. Okay, so the ones that I have grouped together on the top left those are classifying by its angles. And on the bottom, this is how we classify triangles by their sides. Okay, so if we have a triangle and we are going to classify it as acute, what that means is that all three angles must be acute. If you remember, acute means that the angles are less than 90 degrees. Okay, if we are classifying a triangle as obtuse, this means that the triangle has one angle that is obtuse, or one angle that is more than 90 degrees. I don't know if you knew this, but triangles' angles always add up to be 180 degrees, so it is impossible to have more than one obtuse angle in a triangle. So as soon as you see that there is one obtuse angle, we can say it is an obtuse triangle. And for the same reason, for a right triangle to be a right triangle, it has one right angle. Okay, we can't have more than one right angle because that would automatically be over 180 degrees. And remember, a right angle is exactly 90 degrees. Okay, so just as examples here, we can say, okay, so if this triangle is acute, maybe it's all 60-degree angles inside, so all angles are less than 90 degrees. If I wanted to make an obtuse triangle, I might say this is 110 degrees, maybe this is, I don't know, let's go with 30 degrees, and so that would mean this has to be 40 degrees. Okay, so that has one obtuse angle. And then if I have a right triangle, that means that's 90 degrees, and we can say maybe these both are 45. So one right angle. Okay, so those are the three ways that you can classify a triangle by its angles. Now these last three are how we can classify triangles by its sides. So scaling, this means that you have a triangle where all of the side lengths are different. Okay, and we would show a scalene triangle. If you saw a scalene triangle, it wouldn't have any markings on it. You know, so maybe this is 12, this might be 15, this might be 20. Okay, so all the sides are different. Isosceles. So an isosceles triangle has two sides that are equal. Okay. So if you see a triangle and you see that it has these marks on it, showing that those two sides are equal, that would be isosceles. Okay, and the last way that you can classify a triangle by its sides is to say that it's an equilateral triangle, which means all of the sides are equal. And if you saw a picture of it, you would see these marks showing that all the sides are the same. Okay, so it's important that you know which of those terms classifies triangles by their angles versus by their sides. So what we're going to do to practice this is we are going to classify these three triangles by their sides. Okay, so your choices are equilateral, isosceles, or scalene. Okay, so number one, we can see that the two sides marked are equal. That's what those marks mean. And so if two sides of the triangle are the same, we say that that is isosceles. In number two, we see no marks on the triangle. So we're going to assume that means that all of the sides are different, and that would mean it is scalene. And in number three, we can see that all of the sides are equal based on the marks, and so we're going to say that that is equilateral. All right, so now we're going to do the same thing, but we're going to classify these by their angles. So again, your choices are acute, obtuse, or right. So looking at number one, we can see that this triangle has one obtuse angle of 100 degrees and two acute angles that are each 40 degrees. So the rule is that as soon as you see that triangle has an obtuse angle, that means it's an obtuse triangle. Okay, and like I said before, you can't have more than one obtuse angle in a triangle. Otherwise, your total degrees would be over 180 just by having the two angles that are obtuse. Okay, number three, we can see there's a right angle, and it doesn't matter what the other two angles are. As soon as we see a right angle, it's a right triangle. So those ones are kind of nice. As soon as you see obtuse, it's an obtuse triangle. As soon as you see a right angle, it's a right triangle. And number three, we can see all three angles are acute, and so this would be an acute triangle. All right, so that is how we classify by its sides and angles. So now let's turn it to the back here, and let's do some practice with first finding the missing angle in each of the triangles, and then classifying again by its angles and by its sides. So I had mentioned earlier that triangles' angles always add up to be 180 degrees. And if we were in school, I would show you this really cool experiment. And you could probably do this at home, but basically what you do is you cut a triangle out of paper, and then you would rip off each of the angles. And when you put those three angles together that you've ripped off, you will see that they line up in a straight line, meaning they're making 180 degrees. So it's pretty cool. I like showing people that because it's a great visual. No matter what your triangle looks like, if you rip off those angles, you're going to see that it makes a straight angle. So if you look at number one, I know two of the angles in that triangle out of three, and so I want to find the third one, the missing one. What I can do is I can add the two that I have, 58 plus 59, which is 117, and then to find how much more I need to make 180 degrees, I would subtract. And so I would get that that missing angle is 63 degrees. Okay, so that's what they want in part A, find that missing angle. Now part B says to classify by its angles. Okay, so looking at the angles we have, we can see that they're all acute, they're all less than 90, and so this would be an acute triangle. For part C, they want us to classify it by its sides. So looking at the sides, it says we have a side of 6 inches, another one of 5.8, and a third one of 5.7. So since they are all different lengths, this makes this a scalene triangle. Okay, taking a look at number 2. So we're going to do the same thing here. We have 2 out of the 3 angles of the triangle. So to find the third, I'm going to add the 2 that I have, and then I'm going to subtract that sum from 180. Okay, so this ends up being a 90-degree angle, which means if I'm classifying it by its angles, makes this a right triangle. Okay, looking at its sides, they don't give us any side lengths, but what they do show us is that these 2 sides with the marks there are equal. And so when 2 sides of a triangle are equal, that means it is an isosceles triangle. right, looking at number 3. So my two angles that I know are 28 degrees and 31 degrees. And so I take that sum and I subtract it from 180 to get the missing angle. And so my missing angle is 121 degrees. Okay, so to classify it by its angles, because I see an obtuse angle there of 121 degrees, that means that this is an obtuse triangle. Looking at the side lengths, I can see that they are all different, 6, 5, 10.5 meters, and so that means that this triangle is scalene. Okay, one more like that. So our last one here, we have two angles that are 60 degrees, giving me a sum of 120. And when I subtract that from 180, I get that my missing angle is also 60. Okay, so all of my angles are less than 90 degrees, which means this is an acute triangle. And all of the sides are the same, which means it's equilateral. So fun fact, you will start to notice that if you have all three sides of a triangle being the same, it automatically means that the angles are also all of the same. Okay, and if you see an isosceles triangle, so an isosceles triangle like we had in number 2, where two sides are the same, what that means is that two of the angles will also be the same. And if you have a triangle that is scalene, meaning all of the sides are different, that means that all of the angles are also different. Okay, so just kind of a nice little fact to know. All right, so the last two we have here, we're going to include some algebra now in the process. So in number 5, we don't know what any of these angles are equal to, any of the angle measures. So what we can do is we can set up an equation that helps us figure out what each of those angle measures are. Okay, so no matter what, I know that the three angles are going to add to be 180 degrees. So in my equation, I'm going to show that they add together. So add all three angles. And their sum will equal 180 degrees. So that becomes the equation that I need to solve in order to figure this out. So the first thing you should do is combine like terms, and when you do that, you're going to get 15x plus 30 equals 180, and then we can solve our equation from here by subtracting 30 and dividing by 15. Okay, so now that I know what x is, I can take that number and replace it into all of the x's in my angle measures. So because this angle is 6 times x, now I know that it's 6 times 10, which means it's 60 degrees. I can do the same thing here. 4 times 10 plus 20. 40 plus 20 is also 60 degrees. And 5 times 10 plus 10, which is 50 plus 10, is also 60 degrees. Okay, so all of my angles, I'm going to squeeze these in here, are 60 degrees. So to classify it by its angles, they're all acute. So this is an acute triangle. And to classify it by its sides. Now, I'm curious if on your page you guys have these marks. I'm thinking that they just were not printed. But even if it didn't have those marks, I want you to think about that rule that I just talked about. If all of the angles are equal, it means that all of your sides are also equal. So even if those marks weren't there, it's okay for us to say that it's equilateral because we know all of the angle measures are the same. Okay. All right, number 6, last one. So again, I don't know anything about the angles, but I do know that their sum is 180 degrees. So we're going to start by writing our equation, showing that when I add the three angles together, I would get 180 degrees. Your next step is going to be to distribute. So I'm just going to kind of bring all of this down. And I have to distribute that too. And now I'm ready to combine like terms. So 6x plus 8x plus 6x gives me 20x. 2 plus 76 plus 2 gives me 80. And now I can subtract 80. And I can divide by 20. Which gives me that x is equal to 5. Okay, so I'm going to go back and I'm going to substitute 5 in for all of my x's. So 6 times 5 plus 2 is 30 plus 2, which is 32 degrees. Over here, 2 times parentheses 3 times 5 plus 1. So if I treat this like order of operations, inside of my parentheses, 3 times 5 is 15. 15 plus 1 is 16. And 16 times 2 is 32 degrees. And on the bottom, 8 times 5 plus 76. 8 times 5 is 40. 40 plus 76 is going to give me 116. So there are my 3 angles. So to classify it by its angles, I'm seeing that I have one obtuse angle, which means this is an obtuse triangle. And classifying it by its sides, I can see that 2 of the sides are the same. Notice that means also that 2 of the angles were the same, we've been talking about. And so this is an isosceles triangle.